Dear learners, welcome to the course Electromagnetic Fields. In this video, I will be explaining the use of line, surface and volume integrals in electromagnetic fields. Generally, there are three types of integrals involved in electromagnetic fields: line integral, surface integral and volume integral. Already we know that line integral is a single integral, surface integral is a double integral and volume integral is a triple integral. How these integrals are used in electromagnetic fields? Let's start our discussion with line integral. In electromagnetic theory, a charge can exist in point form, line, surface or volume form. Hence, while dealing with the analysis of such charge distributions, generally various types of integrals are required. First, we are going to talk about line integral, how it is used to evaluate the charge distribution. A line can exist as a straight line or it can be a distance travelled along a curve. Thus, in general, from mathematical point of view, a line is a curved path in a space. Consider a vector field F vector. This is a vector. Curved path is from P to R. This is the point P. This is the curved path from P to R. This is called a path of integration and corresponding integral can be defined as line integral of F vector dot dl vectors equal to from P to R. Integration limit is from P to R modulus of F vector dl cos theta, where this dl is nothing but differential length. So, this is called a line integral of F vector around the curved path L. It represents an integral of the tangential component of F vector along the path L. The curved path can be of two types. One is open path as P to R as shown in the previous figure. And another type is it is a closed path as P, Q, R, S and T. In this figure, we discussed open path is from P to R, but the closed path is from P, Q, R and S. Again it reaches to P. This is the closed path. Therefore, the curved path are of two types here, open path and closed path. The closed path is also called a contour. The corresponding integral is called contour integral, closed integral or circular integral, and it is mathematically represented as contour integral is mathematically represented as like this. It is a closed line integral. So, this figure illustrates charge exists along a line from P to Q. It may be a positive charge or a negative charge. It is distributed along the length of the line. We consider the differential length dl. From this we are going to calculate what is the total amount of charge. Q is equal to integral rho L dl. Here we are integrating over the entire length. We get the total charge distribution. So already we know that this is rho L is a line charge density. That means charge per unit length, coulomb per meter. In the previous video, I have explained in detail. Now you can understand how we evaluate total charge exists on a line with the help of line integral. Second one is surface integral. Suppose if the charge exists over the surface of the conductor, the charge it may be positive or a negative charge distribution. We are going to calculate what is the total charge distributed over the surface. Here we are considering the differential surface, which is ds. This is the differential surface we consider. First we write what is dq. Differential charge dq is equal to rho s ds. Is the differential amount of charge due to the differential surface. How we write dq is equal to rho s ds. How we obtain the total charge distributed over the entire surface? With the help of the surface integral, we can calculate the total charge distribution. Q is equal to surface integral of rho s ds. For this case, surface integral is required. So similarly, from this we can calculate the total flux crossing the surface. This figure illustrates the flux crossing a surface. From this we can first consider the differential surface ds. We calculate the flux crossing that surface s with the help of surface integral. Phi is equal to surface integral f vector or ds vector is equal to surface integral modulus of f vector ds cos theta. So here this equation 6, it represents the net outward flux of vector field f vector over surface s. If the surface is closed, it defines a volume. The surface integral involves the double integration mathematically. Next type of integral used in electromagnetic field is volume integral. If the charge distribution exists in a three-dimensional volume, like this, in this figure, it represents the volume charge distribution. Then a volume integral is required to evaluate the total charge. That Q is equal to volume integral rho v dv. Rho v is nothing but the volume charge density. That means charge per unit volume, where dv is the differential amount of volume. So therefore, from this we understand line integral, surface integral and volume integrals are generally used to calculate charge distribution and flux crossing the surface. I hope you would understand the importance of line integral, surface integral and volume integral in electromagnetic fields. Thank you.